It's worth giving some time to the kinds of facts that we'll be using to begin a mathematical system. These will be things like definitions and assumptions that get us off the ground. Informal definitions will describe an object in terms of plain, non-technical language. Certain objects, called primitives, are only ever given in formal definitions. We have to start somewhere, and there are no preceding technical properties or definitions to fall back upon. Examples of these are things like sets, or numerical value, or points, or lines. Formal definitions are of a second order. They describe an object in terms of primitives and in terms of technical properties. For example, a line segment can be defined as a subset of points on a line consisting of all points between two given distinct points on that line. Now, axioms are assumptions about properties of our system that are made right at the beginning, and they are generally unproven. They fall into two categories. The first category are essential axioms, which are considered to be self-evident. To be otherwise or to conceive of the system working in a different way would be nearly unthinkable. These include things like the axiom of non-contradiction that says that a proposition cannot be both true and false simultaneously. Postulates, on the other hand, or inessential axioms, are axioms which can be varied or altered in the context of other systems. We'll assume them to be a certain way at the beginning of our work, but in a different context, they could be imagined to be otherwise. For example, the commutativity of multiplication is a property that we assume about multiplication of numbers, but it's not necessarily true for matrices. Or parallel lines do not intersect. While this parallel postulate of Euclidean geometry might be true in the context of flat space, it's not true in the context of curved space.